Hello everybody, I hope you're all doing well. This is our lecture 5. In this lecture, we will continue the concept of gain and time constant through the example of search tag. In the previous lecture, I promised that I explained the method of integrating factor for solving a linear first order ODE. So let's go through that and then continue the topic after. So I just write the steps that are involved in this method and give you a general perspective of what you expect, and then we apply the same steps to the equation that we found for the search tag in the previous session. So this method is for solving any first order linear ODE in the form of dh dt plus ft times h is equal to gt. In this method, the first step is to find the integrating factor, or in short, we call it IF. And it's very easy. The way it is defined is e to the power of integral of this term, which is ft dt. So this is by definitions. This is just a method to solve this ODE, and this is how people found that it will work. So we just defined integrating factor as e to the power of integral of ft dt. Step 2 is basically multiplying the two sides of equation by integrating factor, which gives us if dh dt plus if ft h is equal to if gt. And if you do this, you'll notice that these two terms, they are basically the derivative of integrating factor times h. So then that gives us the idea for step 3, which is integrating of two sides of the equation. So if we integrate the left hand side of equation, we will get if times h, and if we integrate the right hand side of equation, we will get integral of if times gt dt, and we can perform a step 4, which is dividing the two sides of equation by if, which gives us dh. So with that, I can go back to the search tank example and try to solve the equation that we found in the previous session using this method. If you refer to the notes from previous lecture, you'll notice the equation was in this form: tau dh over dt plus h is equal to kqi. And again, just to reiterate, tau is time constant and k is gain. So in order to make this equation in the same form as the standard for the integrating factor method, I just have to do a simple rearrangement here. So I divide the two sides of equation by tau, which gives me dh over dt plus 1 over tau h is equal to k over tau qi. And now this is consistent with the format that we used for the method of integrating factor. So the first step is to calculate the integrating factor, which is e to the power of integral of this term, which is 1 over tau dt. And this is basically e to the power of t over tau. Then step 2 is multiplying the two sides of equation by if, which gives me e to the power of t over tau times dh over dt plus e to the power of t over tau times h over tau is equal to e to the power of t over tau times k over tau qi. And you can try by yourself and check that this is d over dt of h times integrating factor, which is in this case e to the power of t over tau. It's just a simple product rule, and you can see that this is these two terms are derivative of h times integrating factor with respect to time. So now step 3 is to integrate the two sides of equation, which results in the left hand side of equation will be simple, so it's basically h times e to the power of t over tau, and we have to evaluate it from 0 to t. The right hand side of equation will be integral from 0 to t of e to the power of t over tau k tau qi dt. And I just remind you that these are constant, so we can factor them out of the integral. So if I evaluate the left hand side of equation, it will be h times e to the power of t over tau minus h0, which is the elevation of liquid at time 0, times e to the power of 0, which is 1. It is equal to, then we just factor out the constant part, which is k over tau times qi, and then the integral of e to the power of t over tau dt will be tau times e to the power of t over tau, and we have to evaluate it from 0 to t. So this term and this term, they cancel out. So we will have, again I just rewrite it, h times e to the power of t over tau minus h0 is equal to k times qi multiplied by e to the power of t over tau minus e to the power of 0, which is 1. And then by simple rearrangement, we will have h times e to the power of t over tau is equal to h0 plus k qi times e to the power of t over tau minus 1. Now it's time for a step 4, which is dividing the two sides of equation by integrating factor. In this case, our integrating factor is e to the power of t over tau. So it results in h is equal to h0 times e to the power of minus t over tau plus k qi times 1 minus e to the power of t minus t over tau. And if you refer to the notes from the previous lecture, you'll see that this is the function that we obtained for the elevation of liquid inside the tank. And finally, the previous lecture was slightly longer than usual, so I keep this lecture shorter so you can balance your time and work this out and review these two lectures within a week.